Okay, so good morning, everyone. This is lecture number 12 in this chapter on refraction, ray optics. Up till now, in the previous class, we had dealt with the different types of question, and we had seen what type of question we can expect on refraction and lenses. We had also seen combination of two lenses, two or more lenses. What was the formula for combination of two or more lenses? Do we recollect that? Formula for combination of two or more lenses. The power will be equal to summation of pi. Do we remember this?
Yes, sir.
For lenses, if I have lenses put in contact, the total power, the power of the combination will be summation of individual powers, or I can write it like this: 1 by f, the power of the combination will be summation of individual focal lengths 1 by fi. Do we recollect this?
Yes, sir.
This was for lens, or we could use the same formula if I have a combination of lens and a mirror. Now, what do I mean by a combination of a lens or a mirror? So, we have one lens and one mirror which are placed very close to each other, similar to the condition where we had two lenses placed in contact. I could have a lens and a mirror placed in close contact. Now, if that happens, then how do I get the power of the combination? That is our heading for today, which we are going to start. And this heading is known as combination of lenses and mirrors. So please note down the heading. The heading is combination of lens and mirror. So what will happen in this? If you have a number of lenses and mirrors placed one after the other, what will happen? The first, let us say, the first object is a lens. This lens will create an image, first image of the original object. Now this first image will act as the object for the second lens. That second lens will form a second image. That second image will act as object for the third lens, and so on until we get to the last element, where the image formed by the previous element will act as the object, and that will form the final image. Do we understand what I am telling you?
Yes, sir.
That means if I have to find out the total magnification M which is produced by this combination, how do I do it? And there is a problem, let me just correct it. How do I get the magnification of this combination? To get the magnification of this combination, I simply have to multiply the magnification of each and every element. We have already discussed this. Just so no or yes.
Yes, sir.
Okay, I'll give you a minute to note this down. What you got to note this down? If you have a number of lenses or mirrors arranged, the total magnification will be M1 multiplied by M2 multiplied by M3 and so on. This can come as a question in the exam. Please note it down. Then we'll move on to the next part. I'll give you a minute to note it down. Okay, then the next point that we must again go through, because we'll be using it in this particular chapter, in this particular topic, is the power of a lens. The SI unit is diopter. I know this. I hope you also remember this. Power of a lens, PL, is the inverse of focal length. If the focal length is in meter, it is 1 by F. The focal length is in centimeter, is 100 by F. For a convex lens, the power is positive. For a concave lens, power is negative because their focal length are positive or negative. The positive power lenses are known as converging lenses, and the negative power lenses are known as diverging lenses. Do we remember this? But for a mirror, the power ka formula is minus 1 by F. Power of a mirror, written as L, it should be M. Power of a mirror, please correct it. Power of a mirror, PM, is minus 1 by FM. For a convex mirror, the power is negative. That means it is diverging. For a concave mirror, the power is positive. Remember, positive power. Here we have positive power for a convex lens. Here we have positive power for a concave mirror, and I have told you repeatedly, power is positive. That means that substance, that body is converging. If the power is negative, that thing, if the power is negative, that thing becomes diverging. Do we understand this?
Yes, sir.
Please note it down again, sir, so that we can move further ahead. I'll give you a minute to note it down. Now, since you have completed, what we can do is write the next heading, and the next heading is combination of lens and mirror. What will happen? What will happen if I combine lens and a mirror? For example, if I have, let us say, one, two, two lenses, and then I have a mirror like this. Ting, 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 ting. Let me call this as lens 1, let me call this as lens 2, and let me call this as mirror M. Are you getting my point, bacha? What I have drawn here, are you getting my point?
Yes, sir.
Folk, am I audible and visible to all of you? Yes or no?
What, sir?
Am I audible and visible to all of you?
Yes, sir.
Okay. The focal length of this lens, let me call it as f1. The focal length of this lens, let me call it as f2. And focal length of the mirror, let me call this as fm. Now, I'll ask you a question. I'll give you a minute to think about it. What do you think will be the formula for focal length of this combination? The first question here is, what do you think this combination will behave like? Will it behave like a lens or will it behave like a mirror? That is the first combination. Will it behave like a lens or will it behave like a mirror? Tell me the answer to this one first. Will it behave like a lens or will it behave like a mirror? And how do I find the focal length of the combination? I'll give you a minute to think about it. Give me the answer once you have thought. How will you get the focal length of this combination?
1 by F is equals to 1
One,
by F1 plus F.
1 by f
is equals to
equal to
F1
1 by f1
L1
plus
1 by F2
plus 1 by f2
plus
plus
1 by L1 plus
1 by L1. Okay. Plus what is
1 by
L1?
L lens
Okay. So 1 by the length. Okay. Plus 1 by L2. Anything else? L1 and L2 are the name of the lenses. So we divide 1 by the name of the lens. Is that so? No, I don't think so. I don't think so. We divide by the length of the lens, name of the lens. Okay. So what is going to happen here if you place an object? This entire combination will act like a mirror. Are you getting my point?
yes sir.
This entire combination will act like a mirror. Now, if I have an object here, what will happen is ray of light will go through this. So there will be refraction number 1 here. Then it will, so one time it will get refracted through lens 1. Then it will be refracted through lens 2. Do we understand this? Then it will hit the mirror. From the mirror, it will come back. So there will be a third refraction from lens number 2. Then it will come out. There will be a fourth refraction and it will form an image somewhere outside this. Do we understand this?
Yes sir.
So what I can see is there will be two refractions from this lens. There will be two refractions from this lens. And there will be one reflection from this mirror. Do we understand this?
Yes, sir.
We'll have two refractions from the lenses and you will have one refraction from the mirror. Now, how do I get the power of this combination? The power of this combination will be 2 times the power of the lens plus the power of the mirror. Do we understand this?
Yes sir.
Why the power of the lens is multiplied by 2? Now there are two lenses here, so the formula for this will become 2 times P1 plus P2 plus the power of the mirror. Can anyone tell me why this power of the lens is multiplied by 2?
Two lenses.
Why this power of both the lenses is multiplied by 2? Both the lenses. Power is P1 and P2. Why both the powers are multiplied by 2? Why the power of the lens is multiplied by 2?
Mirror and lens two.
Why the power of the lens is multiplied by 2? Because there are two refractions from each lens and therefore the power of each lens is multiplied by 2. So this becomes the formula for this combination. Do we understand this? Do we understand this?
Yes sir.
Okay. Now remember this combination behaves as a mirror. This combination behaves as a mirror. Do we understand this?
Yes sir.
This combination behaves as a mirror. So I can write this power of the mirror as minus 1 by f, where minus 1 by f is the power of the mirror. That will be equal to 2 divided by 1 by FL power of the lens 1 is 1 by f1 plus 1 by f2 minus 1 by fm. Do you understand how I'm getting this?
Yes, sir.
I've just put the formula of power of the mirror and power of the lens. If I solve this, I will get the formula for 1 by f. 1 by f will be equal to what? 1 by fm minus 2 into 1 by f1 plus 1 by f2. Do we understand this?
Yes, sir.
So these are the two formulas that you must remember. The both the formulas are same. The only difference is this formula is given in terms of focal length and this formula is given in terms of the power of the two bodies. Do we understand this?
Yes, sir.
I will give you a minute to note this down. So I had given you a problem where I had asked you the focal length of the combination of this lens and the mirror. Has anyone done this question, bacha?
Yes, sir.
What is the answer? Tell me.
1 by 5.
1 by 5, is it plus 1 by 5 or is it minus 1 by 5? If it is plus 1 by 5, it will behave as a convex mirror. If it is minus 1 by 5, it will act as a concave mirror. So you have to tell me that also. Is it plus 1 by 5 or is it minus 1 by 5, bacha? Tell me. Don't be afraid.
Convex plus 1 by 5.
Convex plus 1 by 5. Well done. Let me see how we have to do this. So what we got to do, bacha, here is do nothing. I mean, do nothing means we already know what to do. We have to apply this formula. Yes or no? No or yes? Formula is 1 by f will be equal to 1 by fm, the focal length of the mirror, yes or no? The focal length of the mirror minus 2 times focal length of the lens. There is only one lens. Do we understand this? Yes or no?
Yes, sir.
We just put the formula 1 by f will be equal to 1 by focal length of the mirror. What type of mirror is this? What type of mirror is this? This is a convex mirror. Yes or no? No or yes?
Yes, sir. Convex.
Convex mirror, the focal length of a convex mirror is positive. Do we remember this?
Sir.
So it will be plus 1 by 10 minus 2 divided by the focal length of the lens. This is a convex lens. Yes or no? No or yes?
Sir.
Yes, sir. So it will be focal length will be positive. So minus 2 by 10, it becomes minus 1 by 5. 1 by f is equal to 1 by 10 minus 1 by 5. Can you find out the value of f from here? Tell me what is the value of f from here. Can I have your answers, bacha? Yes or no? No or yes? The answer here would be, if you can calculate, minus 10 centimeters. So it will behave as a concave mirror of focal length 10 centimeters. Do we understand this?
Yes, sir.
Now, do you understand how you were getting 5 centimeters or 1/5 or plus 1/5? What mistakes were you doing? Do you understand those mistakes?
Understood, sir.
What mistake you were doing? Tell me. Calculation mistake or you had put wrong values in the formula?
Rank formula, sir. 2 by FL not taken. We are taken 1 by FL.
So, okay, okay, okay. I understand. I'll give you one more so that you can become more confident on that. Are we ready to do that? Let me give you one more on this and then we can move ahead in life. Question number 2. What is this?
Biconcave.
Biconcave focal length is 20 centimeters. And then I have placed, let us see, this is a concave mirror. Do we understand this?
Yes, sir.
Focal length is 10 centimeters. Can you tell me what will be the focal length of this combination? This is a concave lens and this is a concave mirror. Can you give me the answer? I'll give you a minute to win it. Best of luck. So the answer in this case for this combination, again, please go through this. We have a concave length of focal length 20 centimeter. We have a concave mirror of focal length 10 centimeter. When we find out the focal length of the focal length of the combination is coming as infinite. That means it will behave as a plane mirror. Remember, any combination of a lens with a mirror will always behave like a mirror. Can you remember this? You might not be getting much questions on this, numericals on this, but I am very sure that you will be getting questions on this. Will you be able to attempt those questions? Yes or no? No or yes?
Yes, sir.
That takes us to the next part of this lens wala thing, and we are almost to the end of this, which is known as silvering of lens. Now, what do you mean by silvering of lens? It is very simple. As you can see, we have a lens. What type of lens is this? It's a convex lens. It's a biconvex lens. It may be a equiconvex lens as well. And this is a mirror. What we have done, we have just polished this surface of the lens. So we have polished this surface of the lens. It basically it behaves like, when I polish one surface of the lens, it basically behaves like a combination of lens and a mirror. Do we understand this?
Yes, sir.
So if I have something like this, and I hope you can see the diagram. Can you all see the diagram? Can I have raise hands from all of you? Okay. So let me just make the diagram bigger. Bigger is always better. Size matters, and I will just enhance the zoom and probably you can get it bigger on the screen. Okay. Now, once you have, this is diagram number 1. Once you have something like this, what is this? This is a convex lens and one end of that, one face of that lens is silvered. This is nothing but a combination of a lens with a mirror. Now, whenever we have a combination of lens with a mirror, this is refraction number 1. This is refraction number 2. So there are 2 refractions and 1 reflection. Do we understand this? First of all, ray will get refracted from the lens. then it will get reflected from the mirror, then they will again get refracted back through the lens. So there will be two refractions and one reflection. Do we understand this?
Yes, sir.
Please draw this diagram and then we will write the formula for this particular case. Now we'll move ahead and write the combination curve formula, and the combination curve formula for power is this. Do we all see this? Power
Yes,
of this
sir.
combination will be 2 times the power of the lens, one lens, 2 times the power plus the power of the mirror. Do we all see this? Yes or no? No, yes. Can I have reason that we all see this?
Yes, sir.
Yes, sir. That is the formula for power. Power of this combination is 2 times the power of the lens plus power of the mirror. As far as the formula for focal length is concerned, they have done a mistake, very small but very big mistake. Can anyone tell me what is the mistake in the formula for the focal length? I will be very happy if you can tell me that. The formula for the focal length has a mistake in the sheet. Can you point out that mistake? I've just told you the formula for power. Before that, I told you the formula of combination of lens and a mirror. Can you point out the mistake in the formula for the focal length of the combination? Yes. What is the mistake in the formula for focal length? Yes, I'm waiting.
Minus 1 by FM.
No, that is not correct. It is minus 2 by FL beta. The formula of focal length, I have just told you 1 by FM minus 2 by FL. Do you remember this? I just not told you that. Yes
Yes,
or
sir.
no? No,
Yes, sir.
yes.
Yes, sir. Yes, sir.
Okay,
Yes, sir. Yes,
okay,
sir.
okay, okay, sir. So please note down this formula, sir. The formula is same. The concept is same. It is just asked in a different way. I'll give you a minute to note it down. Well then, I think you have noted down the formula of silvering of lens. With this formula, with this concept, we have reached a stage where we can say that this part of the topic where we were dealing with lenses, curved lenses, is sort of over. There's one more thing about curved lenses which is remaining, which is microscopes and telescope, but they come in a different category. They come in optical instruments. So we will be studying them in optical instrument. As far as this lenses wala part is concerned, we are done with lenses. What we are done with? We are done with refraction at plane surfaces. We are done with refraction at spherical surfaces. We are done with refraction at lenses. Now we have to move into our next topic, and the next topic is refraction by a prism. We will start this next topic, but before going on to the next topic, it's always a good habit to go through what we have studied till now and ask me any doubt if you have. So I'll give you 5 minutes. Go through whatever we have studied till now. Ask me any doubts if you have, and then we'll start with the next topic, which is refraction by a prism. So I'll give you 5 minutes. Till then, take care and study. I'll be back, and we'll start with prism